Welcome to 2-8. I told you we were going to come to this. This is explaining multiplication and division related facts. We now have a multiplication fact triangle. And just like with addition, we've got the product is going to be here in the top, and the values being multiplied together are going to be in the bottom corners. And we're going to see that 6 times 5 is equal to 30. Remember that the direction is important, so 30 divided by 6 is equal to 5, and 30 divided by 5 is equal to 6. We've got 4 math facts available to us. Just like we had for addition, there were 4 math facts here. We have 4 multiplication facts. The first one is that 6 times 5 is equal to 30. The second one is making use of the commutative property of multiplication and tells us that 5 times 6 is equal to 30. How many math facts is that? That's 2. Count them. 2 math facts. The other 2 have to do with the division of the product. So 30 divided by 6 is equal to 5. 30 divided by 5 is equal to 6. So we can see how we can use this, and we'll be able to use it to help us solve some problems. Let's take a look a little bit further here in the lesson. You should be reading through 2-8, taking notes where appropriate. We have a property or two in here. Multiplication property of equality tells us that if we multiply both sides of an equation by the same number, it's still equal. The sense of the equation might change. In other words, up here we have that a negative 3 times 5 is equal to a negative 1.5. Well, we can multiply both sides of this equation by 10, and if we do that, we end up with having that a negative 15 is equal to a negative 15. It's maintained its equality. It's still equal, although the result of the calculations here are different. We have shown that it's still an equality because we've done the same thing to both sides of an equation. The division property of equality tells us that if we divide both sides of an equation by the same value, as long as that number is not 0, we're not allowed to divide by 0 in our algebra. We consider that to be undefined. As long as it's not 0, then if A is equal to B, then that A over C is equal to B over C. Or we might say A divided by C is equal to B divided by C. That fraction bar takes the place of our division symbol. The math facts we have in this, there are 4 math facts. It's the 2 products using the commutative property of multiplication, and it's the 2 computations for division when we have the 2 division facts. Related facts to this is that if AB is equal to C, then BA is equal to C, C over B is equal to A, and C over A is equal to B. There are 4 math facts available, and we can see that in our first equation. Here we have that 16 times x is equal to 192, so the product is up here, 192. We have that 16 times x is down here. We're going to make use of the math facts, and the one that really works for us is 192 divided by 16 is going to equal x. So we go ahead and we do that division. We see that 16 goes into 192 12 times, and 12 is equal to x. We could check this answer by multiplying 12 times 16 and verifying that it works. The next problem, the next thing to talk about here is this role of 0 in multiplication and division. 0 is, in some cultures, is called the annihilator. You multiply something by 0 and it all goes away. It just becomes 0. Any number multiplied by 0 is equal to 0. This is kind of a useful thing when we're dealing with some equations, and it might help us to resolve some things and eliminate some terms. We want to be careful, because if we multiply both sides of an equation by 0, we get 0 equals 0, and we don't know anything about it. All we knew is that this multiplication property of 0 is true. However, the zero product property could be helpful. In this case, if two numbers, a and b, their product is equal to 0, so a times b equals 0, then that means one of three things are true. Either a equals 0, or b equals 0, or both a and b equal 0. That is our properties with 0. The multiplication properties of the number 1 are useful because 1 is our multiplicative identity property. Try to say that without spitting. The multiplicative identity property tells us that for any real number a, that a times 1 equals 1 times a, which is equal to a. Let's pick a number. How about 5? 5 times 1, that's equal to 5. That's the multiplicative identity property of 1, which leads us to the idea of creating a 1 through the multiplicative inverse property. If we have a number, a, for example, and a is not equal to 0, then 1 over a times a is equal to a over a, which is equal to 1. We could multiply both sides of an equation by a multiplicative inverse and create a 1, which is a multiplicative identity. The 1 over a is what we call the reciprocal of a number. A reciprocal is the value in which we could multiply a number by and have the result equal 1. And I'll take you through example 3 in just a minute. First, I wanted to go through some of the what's in the lesson. I want to go through a couple of the multiplication fact triangles. And your assignment is covering the ideas and applying the math. If you have questions, talk to your friends, bring it up with them. If you still have questions, come and see me. Write them on the board. Again, give me a chance to review what you've got so I can determine whether it's time for a lecture or a one-on-one lesson. Let's go on to some math fact triangles. All right, let's take a look here at explaining a math fact, multiplication fact with the triangle. So here's our problem. Let's see. We've got 12y equals 180. Easy enough to do. We want to take the product goes at the top, 180. We have division, we have multiplication, and it was 12 times y. 12 times y equals 180. We have our properties, and we have our multiplication property of equality, which tells us if we multiply both sides of the equation by the same thing, we will end up with the same result. And in this case, because the math facts up here are that 12 times y equals 180, y times 12 equals 180, 180 divided by 12 equals y, and 180 divided by y equals 12. So I want that 1, right? 180 divided by 12 equals y. That's the one we want. But we could get to that with properties by using our inverse property. 1 over 12 times 12y is equal to 180 times 1 over 12. I've multiplied both sides of the equation by the same amount, 1 over 12, 1 over 12, so it's still equal. And now I've used the reciprocal of 12, So 1 over 12 times 12 is just 1. I end up with 1 times y, and that equals to 180 over 12. And 1 times y is just simply y. 180 divided by 12 is 15. And we get that y equals 15. Now we could have used math facts, not algebra properties, and have jumped right down to our solution. 180 divided by 12 is equal to y. 180 divided by 12 is equal to, oh, we just did that, right? 15. So 15 equals y. We could check it by multiplying 12 times 15, and indeed we get our solution that 15 is equal to y. Okay, let's take a look at another kind of problem we might want to deal with here. Okay, let's look at a slightly different problem, and that's looking at some that might have some zeros in them, and we'll bring that up. Okay, so here in this example, let's look at 0q, and that equals 0. And what this tells us is we have 0, division, multiplication, and that 0 times q is equal to 0. That gives us our one possible problem here. And so 0 times that, and q could be 0, or it could be some other value. We don't know at this point. All we know is that the product of 0 and q is equal to 0. Let's look at a different one. And let's say we have this one. 0 times 5 is equal to q. So I've got q up here. I've got my division symbol, multiplication, and I have 0 times 5 equals q. Now in this case, I have a little bit more information in that I know that 0 times 5 is 0, and 0 now equals q, and I have enough information to conclude that indeed q equals 0. Okay, one more, and then I'll, quit. Well, maybe not. So 9q equals 0. My product is 0. My division, multiplication. 9 times q is 0. And what I know from this, if 9 times q is 0, I can divide both sides by 9 or multiply by 1 over 9. Over 9 times q equals 0 times 1 over 9, and so q equals 0, because 1 over 9. And my math facts tell me this as well, that 0 divided by 9 is equal to q, and 0 divided by 9 is 0, so I get again that 0 equals q. So those are some of the math facts we can pull out of this for this type of a problem. Now let's look a little bit. I had mentioned that we should look at some of the reciprocals. So let's go ahead and do that. And we'll get a new page in here. Let me get rid of this one. We'll get in a new page and we'll look at a few reciprocals. So let's find the reciprocal of some numbers. So these are reciprocals And let's find the reciprocal of 5, shall we? And what I means is there's some number that it's reciprocal where 5 times that number is equal to 1. Well, I could make a little math fact triangle, and then I could solve that for 5. So let's see, that's a 1, 5, r, fraction bar, multiplication. And so that tells me 5 times r is equal to 1. I want r, so 1 divided by 5. 1 divided by 5 is equal to r, 1/5. That's our reciprocal. So 5 times 1/5, 5 over 5 is just 1, is equal to 1. I've got the reciprocal for that particular value. Let's try another one. We'll erase this stuff, and we'll put in another value. So let's try a fraction, shall we? And let's look at this one. We'll say 3 divided by 11. What's the reciprocal of this? In other words, what am I asking? What I'm asking is, what number can I multiply 3/11ths by to have it equal 1? And in that case, I'm multiplying it by its reciprocal, which would be 11 over 3. 3 over 3 is 1, 11 over 11 is 1, and that all equals 1. We could use our math fact triangle to help us with that one as well. If I wanted to know what it was, I have 1, I have 3 over 11. This is division, multiplication, and I'm going to use r again for reciprocal. And I know that I want that 3/11ths times r is equal to 1. So 1 divided by 3 over 11 is equal to r. Well, I'm just going to simply take the inverse, because when we divide by something, we invert and multiply. So that's now equal to 1 times 11 over 3 is equal to r. So r equals 11/3, since 1 is our multiplicative identity. And again, we see that that gives us our reciprocal. Let's try another one that I am going to show you how to do this as a shortcut. Be careful about how you use it. Sometimes it could be inappropriate to do. The context of the problem may help you with that. But for many problems, this is actually the easiest and quickest way to deal with this type of a problem. So here is, what is the reciprocal of 1.125? Now, we could go to the trouble of trying to figure out what fraction this is equal to. But what we're going to find is we don't really need to do that. If I want to know what the reciprocal of this is, what's the reciprocal that allows it to equal 1? Well, the reciprocal of this is the inverse of 1.125, and the inverse is 1 over 1.125 times 1.125, and that's going to be equal to 1.125 over 1.125 is going to be equal to 1. I have found the reciprocal for this decimal form of the equation. So we've got some reciprocals. Let's try one more. We'll go with a negative this time, and we'll see how we could do that. And again, we have to remember it needs to equal 1. And we have to pay attention to our signs. For those of us that are sign challenged, we need to make sure we check that to get it right. And let's take a look at negative 17 times our reciprocal. It's going to equal 1. Well, if I had, let's see, negative 17, and I take the inverse of that, that's going to be times, and a 17, negative 17 over a negative 17, a negative over a negative is a positive. I have a negative 17, over a negative 17, and that's going to equal 1. I now have solved for the inverse of this term. Your assignment, again, is to go through covering the ideas and applying the math. Bring your questions in, talk to people about it, write them on the board. Get ready for the mastery quiz. Good luck on it. Looking forward to seeing you on the mastery side of things.